Hello, class. This will be the last of the recorded lectures for chapter 9, and we're going to finish by talking about calculation of uh, p-value hypothesis testing using proportions. And so this is the idea of uh, using technology or using the z-score table to calculate the p-value or probability. And so I'm going to walk through all three of these right now. And so just from the previous recorded lecture, we walked through this problem using the critical value calculation. And so we're going to do the same thing, walking through the other calculations that I talked about as well. And so with that, we ended up with test statistic values that look like this. And so we walked again through this calculation. And so I actually have it up on the whiteboard here. So it's a little bit easier to point to. And you could see that this is what we did last time. And then our strategy was that this Z critical value, right, was 1.645. And the question is 3.31 was greater than 1.645. And what did we do? We rejected the null hypothesis. So now we talk about this p-value, right? And this p-value stands again for the probability. And again, since it's a right tail test, we use this alpha, and that would be 0.05. Or if we think about it in percentage, that would be 5%. So there's three ways to find the p-value. The way that you could use is the z-score table, right? And if I pull up the z-score table, just like we did in the other calculations in previous sections, what you would do is find the z-score value, and that would give you your probability. So there's two ways to do this, right? You could find the positive z-score number, right, and subtract it from 1, or forget the math, right, and find the negative z-score because of symmetry, and that gives you the left tail, but remember the left tail and the right tail are exactly the same. And so what was that again? Of course, my memory is bad. Let me look again. 3.31. I'm glad I looked. I was going to do 1.3. So 3.31 in this calculation is 3.3. And then the 1 value here would be 0.0005. And so if you wanted to do the p-score, whoops, timeout, rewind. So it's 3.13. I was right at the beginning. So let me go back to my whiteboard, and you can see that I copied it wrong. So if I go back to my whiteboard and do a little erasing here, if you got out your calculator, it'd be 1.3. Okay, so let's rewind again and look at the p-score for 3.13. And so if we go back to our table, minus 3.1 and then 1, 2, 3 with 4 decimal points, you can see it's 0.0009. And so the idea is that you read it off the table. And so the p-value of 0.0009, or if you did percentage, it's only 0.09%. So you could see that 0.09% is way less than 5%. So again, by the right tail idea here, we reject the null hypothesis. So this is how I had to do it when there was no cool technology to help you with these calculations. But now we have it. So let me show you a couple of things that you could do. So the first thing you could do is use your fancy calculator if you have it. And the idea is that, first of all, you could use your norm CDF calculation after you calculate the test statistic and plug that value of the z-score in there, and out will give your probability. And you can see here it was 0.30874 and some change. So typically, because the Z tables give you 4 decimal points, you typically round to 4 decimal points. And so you could see that value would be 0.0009. And so you could use the norm CDF function to do that. If you went to the spreadsheet, you could do the same thing using the appropriate function. And so if you pulled that function up, it is norm.s.dist. And so the .s gives you using the z-score. And so in this case, if you plug in the z-score 3.13 and hit true, you're going to get a really big number, right? It's going to be 0.999. Now remember, when you do that calculation, all right, let me pull up the whiteboard here real quick. And again, for symmetry reasons, hopefully you can see this down there, right? You're way up here. So you calculate all that. So to get this p-score or p-value, you have to subtract it from 1. So when we do that using the technology, come back up here, excuse me, and it would be equals 1 minus this number. And you can see we get the exact same number as you used your calculator with regard to that. And so the last of the calculations is that, let's see here, find the right slide. Here we go. Is that the TI-84 Plus has these testings for z-test, t-test. You're going to see we're going to do some sample testing. Many of you have already used the z-interval and the t-interval test. Well, now we have the proportion z-test, which is called prop z-test. So if you walk through that, you click stats test and then prop test, the number 1, and you plug in the values. And so you plug in the values of the appropriate p-values, etc., and out will come your calculation as well. And so that gives you a feel for using the technology. So maybe we should do one more example here. Let's see. Yeah, let's do one more example. And so this example, let me pull it up for you. So this example here is a nationwide survey of working adults, indicates that 50% of them are satisfied with their job. That's pretty sad. The president of a large company believes that more than 50%. To test his belief, he random surveys 100 people and 54 of them are satisfied. Can he conclude 50, that it's more than 50? All right. And we're going to use, again, our significance level of 0.05 or 5%. And so again, if you walk through the criterias of NP and N1 minus P0, you see that we are okay with the criteria. And then this is a little tricky because you don't know how many total employees. But in this case, there are 2,000, which is 20 times more than, because 100, there's more than 2,000, and which implies the 20 times greater of the total population. So again, when you do this calculation, let me pull this up here on the slide. And so in this case, our P0 is 0.5. And again, they want it to be better. And so you could see here on the critical value, we are going to use the z-score of 1.645. And so how do you find p hat? Well, p hat is the x over n. And so 54 divided by 100 is 0.54. So what happens? Well, look, when you do the p calc or the z test calculation, and you just plug all those numbers in, you get a z-score test of 0.8. And you see 0.8 is less than 1.645. So we do not reject the null hypothesis. So unfortunately, it's not, you can't conclude that it's going to be greater than 50%. So the question is, if you were doing the p-value test, right? How would you do the p-value test? Well, if we go back to our spreadsheet calculation, remember if we do 0.8 for the z-score and pull out norm.s.dist, you would plug in 0.8 and true. And remember, since we're doing the right tail test, we're going to have to do the 1 minus, right? So in this case here, we get a little more than almost 79%. And so that would be left tail. So to do the right tail, we do 1 minus. And so when you do that, you can see that it's just over 21% on the right tail, which is not a high confidence level, right? And so in this case, that you could see that you would do not reject the null hypothesis using the p-value test, because what did we use? 5%, I believe. Yes, 0.05 or 5%. And that is much, much less than 21.2%. So again, you won't reject, so you do not reject the null hypothesis. So finally, that concludes the recorded lecture for this section and of chapter